5.3 Exponential Functions. So as with the previous sections of this chapter, this section is also review. The majority of this chapter is coming from Math 1. So I want to approach this as if you have been taught this lesson before. Gotta ignore my dog. He's mad because I won't let him in the house because he whines like that. So, quick review on adding, subtracting, multiplying exponents. I'm not going to talk too much about this here with the add and multiply. F of x equals a to the x. That is how we are used to seeing this in Math 1, but with different variables. In Math 1, we see this as y equals a times r to the x, where a ends up being your y-intercept, your zero figure, and your r is your ratio, what you multiply by. So please don't think that this is going to be difficult stuff. If you want to practice using exponents in your calculator, here's one that you can practice using to make sure you understand how to use that button, because we will be using it as we move into graphing. So this first example, determine whether the given function is exponential or not. That means when you're looking at the table, you are looking for multiplication. Is it increasing through multiplication from one term to the next every single time? And for those that are, identify the value of the base. That is what is being multiplied by. So again, this curriculum, this book uses f of x equals a to the x. You are used to y equals a times r to the x. We're looking for r, essentially. So if I look at this example here, I have my table and I can see that the growth is multiplying by 4 every time. And you might choose that you don't want to look at the fraction. You might want to not look at the fraction yet and just be like, oh, from 1 to 4, it's times 4. 4 to 16 times 4. 16 to 4 times 4. And then go back and then double check. If I multiply 1/4 by 4, do I get 1? Yes. Since it is then multiplying by the same number, this is exponential, and the value of the base is 4 because that is what is being multiplied by. All right, moving on. Now we're going to look at some graphs. So let's just review really quick how we can graph these. I strongly suggest a table of values. If you're really good with transformations, you will be able to use transformations. You might want to write this down. Negative exponents reflect over the y-axis, and a negative base will reflect over the x-axis. So one flips it left and right, one flips it up and down. I also have some examples of transformations over here that you might want to pause and write down. When r is greater than 1, when you multiply by a number greater than 1, you have a growth function, and your asymptote is at 0, y equals 0. If you have a negative exponent, just a quick review. If I have 2 to the negative 1, well, that makes this 1 over 2. If I have 2 to the negative 2, that's 1 over 4 because 2 squared is 4. So that negative exponent makes your ratio a fraction, which turns this into decay. So your graph, instead of growing exponentially, will decay exponentially. So nice little shortcut there. And then if your rate is negative, then your graph will actually flip over the x-axis and go from a growth graph to a decreasing graph below the x-axis. And then quick little shortcuts here. So how do I know when to move a function left or right? Well, with our polynomials, with our quadratics, basic cubics, our parent functions of polynomials, and all the other parent types of functions, you guys are used to, if it's inside with the X, you move it left or right and change the sign. If it's by itself, you move it up or down and you don't change the sign. The same rule applies with exponentials. If there is a number being added or subtracted to the X, that is what you move left or right. And if there's a number being added or subtracted by itself, that is when you move up or down. When it moves up or down, the horizontal asymptote moves with it. So your horizontal asymptote is usually y equals 0. But when you see an up movement, let's say I go up 3, now your horizontal asymptote, I hit the mouse. Now the horizontal asymptote is going to be y equals 3. So pay attention to those movements. If you do not want to use transformations to go through any of these graphs, you are welcome to just make a table of values. So I am going to do that. I'm going to make a table of values for you. Here, I'm going to start with 2 to the 0. Well, that's 1. Well, I'm not really going to do a table of values. This is just going to be really quick. So I'm going to put a point at 1. 2 to the 1 is 2. 2 to the 2 is 4. And now I can see the curve. 2 to the negative 1, 1/2. This will not cross the x-axis. That is your asymptote. And here is your graph. So that's your very basic exponential function. Now, b. b has a negative exponent, which means this is going to become a decay function. But just to prove it to you, let's plug in some values. Let's say I plug in 3 to the negative 1. Or, sorry, I plug in negative 1. Well, that means this is 2 negatives, so I get 3. When I plugged in negative 1, I got 3. What if I plug in 0? 3 to the negative 0 is 1. What if I plug in 2? So this would become negative 2, which is 1/9. So I can see my curve. Once you see your curve, you don't need to continue to graph, and my asymptote is at y equals 0. See how the negative exponent made this become decay? So when I look at C, this negative exponent is actually going to make this graph decay, where in A it was growth. So instead of 1, 2, it's going to be negative 1, 2. So here would be my graph. Sorry, that looks so bad. But this 1 tells me I need to go up 1. So since I go up 1, my horizontal asymptote is now at y equals 2 instead of 0. So everything moves up 2. So let me draw in my horizontal asymptote. And instead of my graph being at 0, 1, it's going to move up 2. So from 0, 1, it becomes 0, 3. Instead of negative 1, 2, it's negative 1, 4. Everything moves up 2. And then I have my graph. And you get the same thing if you use a table. And then in D. D is negative e to the x. E is 2.718 and then some following decimals. You are welcome to use a calculator here. I strongly suggest the use of a calculator. So negative e, I'm going to start with 0. E is the only thing that is to the 0. So this is negative, and then e to the 0 is 1. So 0, negative 1. Now I'm going to go negative e to the 1, which is negative 2.718 and da 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 da. So I go to 1 and it's negative 2.7. That's enough for me to create this graph. There was no up or down shift, so I know my horizontal asymptote is at 0. Here's my graph. Not too hard. Again, plug in points if you need to. Please try not to cheat and use Desmos to make this easy for you. You don't get Desmos on a quiz or a test, so you do need to be able to do this. So in example 2 now that we've had our refresher of graphing exponential functions, I'm going to go through this one a lot quicker. So 2 to the x we did graph back in the previous part. This plus 1 means we're going to go up 1. So your horizontal asymptote is at y equals 1. And if I plug in 2 to the 0, 2 to the 0 is 1 and 1 plus 1 is 2. So when I plug in 0, I get 2. When I plug in 1, 2 to the 1 is 2 plus 1 is 3. And that's enough to create my graph. And again, that's plugging points. I don't need to plug points. I already did B for you back here. I'm not going to do that one again. But, let's talk about domain and range. Domain of exponential functions. That left arrow keeps going to the left. That's negative infinity. This right arrow keeps going to the right. That is positive infinity. For your range, your left arrow is approaching an asymptote. So now you have to pay attention to what your asymptote was. Since my asymptote was 1, it is approaching 1. And the right arrow is going up to infinity. And then we already have our horizontal asymptote. Actually, let me label that. There's our horizontal asymptote. And let's see. Okay, let's go ahead and do C. I am not going to use a table of values here. I'm just going to make a very rough sketch. There is no adding or subtracting, so my horizontal asymptote is at y equals 0. The 4 is your starting point. That's your y-intercept. The 1/3 means that this is decay because it's less than 0. So this is how I'm going to do this. Very, very quick. I'm going to start at 4 for my y-intercept, and it's decay. And it is going to go down. There's the graph for C. Domain, again, negative infinity to infinity. Your range, what's your horizontal asymptote? 0, and that goes up to infinity. And we already have our hat. And then for D, I see a +3, so that means we're going to go up 3, which makes our horizontal asymptote y equals 3. Now I need to pay attention to 3 to the x minus 1. And I don't remember the transformation. Let's say that that is the case. So I do want to start plugging in some values. My first value is going to be 0. I want to find that y-intercept. So 3 plus 3 to the 0 minus 1. Well, that's 3 plus 3 to the negative 1. And take your time with this. This is 3 plus 1/3. So 3 1/3 is your y-intercept. So barely above the asymptote. Now I'm just going to plug in one more number because I just want to make sure I have the direction correct. I'm going to plug in 1. 3 plus 3 to the 1 minus 1. 3 plus 3 to the 0. 3 to the 0 is 1, so I get 4. When I plugged in 1, I got 4. So I can see the direction of this graph now, and I am done. If that doesn't make sense, watch it again or come with questions ready when we get back into class. Oh, I forgot domain and range. Sorry. Add the asymptote. Domain again is negative infinity to infinity. Range, what's our asymptote? 3, and it goes up, so positive infinity. Okay. Now we only got a couple more to go. And the last couple are pretty much just algebraic type of questions. To solve an equation, when your variable is an exponent, you either need to use logs, if you remember that from Math 3, which we will actually get to later on in this course, or you need to know that if your base is equal, it follows that your exponents will equal. So if I'm looking at A, since my exponents are since my bases are 6 and 6, that means I can ignore my bases and just work with my exponents, which makes x equal to 3. In B, B's a little trickier because I do not have the same base. Since this is 4 to the 2x, I need to rewrite 16 with a 4. 16 is 4 squared. So 4 squared, and then I bring down that 4. My bases are the same. So I can ignore the bases, and I'm left with just the exponents. 2x equals 8, so x equals 4. Oh man, this just keeps getting harder. So now in C, I see fractions. And I need to remember fractions come from negative exponents. For example, the one I showed you earlier, if I have 2 to the negative 3, well, that's 1 over 2 cubed, which is 1/8. So if I see a 1/8, I need to remember that that used to be a whole number with the negative exponent. So I'm going to put these back with negative exponents. And I'm not going to worry about changing the base yet. So 1/3 can be rewritten as 3 as long as I put a negative exponent. So just a -1, and I bring the x down. 9 is 9 to the -1. Now I'm going to work to write these with the same base. 9 is 3 squared. So this is 3 to the -x equals 3 squared times -1. Again, you have to bring the original exponent down. Since my base is equaled, I am left with -x equals -2 and x equals 2. And then lastly, at least it's not a fraction. 125 is the same as 5 cubed. So this is 5 to the x squared plus 8. 125 is 5 cubed. Bring down the 2x. Now I can ignore my bases. X squared plus 8 equals 6x when I multiply the 3 and the 2x. Now I need to move the 6x over so I can solve for x. I need all my x's on one side. So I have x squared minus 6x plus 8 equals 0. We really need to be able to recognize now that you need to factor what multiplies to 8. 4 times 2, 1 times 8. Well, which of those could give me a -6? A 4 and a 2, as long as they are both negative. So x equals 4 and 2. And that wraps up that example. Pretty straightforward with the algebra. Now this last one. In this last example, you are given the graph. You have to write the equation. So the formula that is in your notes is our math analysis formula, where k is the initial value. We know that as the y-intercept. K is your ratio. So we are used to seeing this again from Math 1 as y equals a times r to the x. So please don't overthink this. I'm going to do this the same as what's in your notes, and then I'm going to show you a second way to do this. And then you guys can decide if you like the second way better. I would suggest writing it on a Post-it note and then stick it over this example and ignore what's underneath it. So since my k is my initial value, I have that in my y-intercept. My ratio, I don't know my ratio, but I am given a random point on the graph, which is my xy. Just call it xy. Any point on the graph can be called xy. But I'm going to use the one that they're giving me. So I'm going to use this equation down here. Y equals k times a to the x. In place of y, I put -6. In place of k, I put -1. A is what I'm looking for, and x is 1. divide by -1. So I get 6 equals, and then a to the 1 is just a. I left off p. P is always going to be 1, so we do not need to worry about finding p. Okay, so I threw that out of the work. So once I have a, I need to plug back in, but the equation is going to be y equals, what was my k? -1. You always have to put your starting value. What am I multiplying by? 6. And then it's to the x. It's not difficult work, but the second way I'm going to show you, you might decide is a lot easier. Now, knowing that k is the initial value of the y-intercept and r is the ratio, I'm going to take these 2 points and I'm going to make a table out of them. When x is 0, y is -1. When x is 1, y is -6. What do we multiply by to go from -1 to -6? We multiply by 6. That's your ratio. So y equals, what was my y-intercept? -1. What's our ratio? 6 to the x. You take your pick. On this next one, I'll go ahead and show you both again, and then you can decide. This is my k. This is my xy. So y equals k, a to the x. Y is 4, k is 2. I'm looking for a, x is 1. Divide by 2, a equals 2. So y equals, what was my original value? What's my y-intercept? 2. What are we multiplying by? 2. Or just make a table. When x is 0, y is 2. When x is 1, y is 4. What are we multiplying by? 2. So I have my y-intercept is 2. My ratio is 2 to the x. You get the same thing. You decide. If you have questions, please make sure you ask me in class tomorrow when you see me. And if not, you'll be able to just get started right on your classwork.